Hi, in this video we're going to look at the final question on the Core 2 Practice Paper 1. This is question 9. I've made these papers for AQA, but it is suitable for the exam boards if you're having a go at it. You can download the paper from below if you've come across my channel, but without getting the paper sent to you. If you have the paper, then obviously you've found the link to the playlist, so that's good. If you need any more questions, contact me on Twitter at Mr_G_Walton. Okay, so we're going to look at sketching the graph first of all of y equals 3 to the x. Little tip for you, when we're doing these we need to be making sure that we label it up correctly. Let's have a little think about what's going to go on. So when x is nothing, y is going to be 1, so we're going to go through this point here. When x is 1, y is going to be 3, so it's going to be through this point, and we know the general shape of these. I'm right-handed, so a little tip here is to start on the right hand side and then sketch, and that way you'll find it a little bit smoother. If you don't have the numbers on the grid like I do here, make sure you label them on nice and clearly so the examiner can see. So any intercepts between x and y axes, make sure you label those on. Okay, first part, 2 quick easy marks. Now there's an actual mistake on my question here. Your paper will say use logarithm to solve 3 to the x equals 15, and that's what we're going to be working. So 3 to the x equals 15. What we need to do is think about how our logs work. Well, logs work in the following way. So let's use logs to solve this. Now you should remember that we have log of base 3 of 15 equals x. This is what it means. Remember, when we're doing logs, it's the number down here. This to the power of this equals this bit here. Now if you've got a calculator that does logs to different bases, then you can just type this in and you'll get that x equals, let's do it on my calculator, 2.46 to 3 significant figures. Alternatively, if you don't have a calculator like that, you're going to have to do it in a slightly different way. You can do it using your base 10. So you can do log to base 10, which is just a normal log button, 15 divided by log to base 10 of 3, and that's going to get you exactly the same answer, 2.46. Okay. And then the final part, part C, it says write an expression for f of x when this curve's been translated by a column vector 2, 0. So what we need to remember is what happens with these column vectors. 2, 0 means 2 units to the right. So this curve will now be somewhere over here. Okay, so it's been translated 2 units to the right, something like this. Okay, so we're not being asked to draw it, we're just being asked to think about what's going on. 2 units to the right, that means that the x value, something's happened to in the x direction. Now from your Core 1 knowledge of quadratics and when they move, think about what happens inside the brackets, so things next to the x inside the brackets. Hopefully you remember that things do the opposite to what you were expecting. So if we're looking for an expression of f of x here, then we're still going to get 3 to the x, and it's something that's happening to the x value, and what's happening is we're moving it 2 units to the right, or minus 2. So f of x equals 3 to the x minus 2. Okay, and then this is the final part for the revision notes then. Make sure that you know what the graph of y equals a to the x looks like. Okay, so if we're drawing that out very kind of roughly, we're going to get something that looks like this, where it crosses through at 1. When you're sketching any graphs, make sure you label any axes, any x and y intersections on your axes there. And when you're thinking about your transformations of graphs, make sure that you learn your basic reflections, translations and stretches. So you need to know f of ax and af of x. You need to know minus f of x and f of minus x, and you need to know what f of x plus something, let's call it a again, and what f of x plus a does. Okay, very quickly we'll go through these. So the first ones, this little group here, this family here, are all to do with stretches. If it's outside of the bracket, outside of the f of x, it's just something to do with an up and down direction. Okay, so it's always going to be the same. If it's on the outside of your f of x, it's up and down. In this case, this is a stretch. This one is going to give you a stretch scale factor A, and this is in the y direction. So that's in the y direction, whereas this one is a stretch scale factor 1 over a in the x direction, or parallel to the x-axis. Okay, so we'll say parallel to whichever axis it is. This next little group here, we've got minuses, so these are your reflections. So these are all reflections. Again, if it's on the outside, it's an up and down reflection. On the inside of your brackets, a left and right reflection. So this one is a reflection. This one here is a reflection in the x-axis. Oops. Reflection in the x-axis, up and down reflection. This one is a reflection in the y-axis, left and right reflection. And the last one are the translations. So these are all translations. Again, on the outside of the bracket, it's an up and down thing. So the first one translates by the column vector 0, A, so up and down. And this one translates by the column vector minus A, 0, left and right. Okay, hopefully that's been a little bit of use for you. You can write this in your own kind of way, make it a lot neater and tidier than mine. You can do little pictures as well to help you, but these are key things that you need to know. Okay, any more questions, get in touch, and hopefully you've done well on this paper. I'll do another one soon. Good luck, see you soon. Bye.